So this map in itself, because we queried all the data, it has all the data for that year shown right here. But we also have this AI chat on the right here. So let me quickly zoom in here. So I can say something like, show me accidents from Osaka between 10 a.m. and 5 p.m. So what should be happening right now is behind the scenes here, it's going to go in and change the underlying query that is visualizing this data, and then query the data, this main data right here, in exactly the way that we asked it to. So it should go in and figure out that, hey, I have a prefecture column, which I can use to find Osaka. That's what it's doing right now, as you can see. And then it's got this hour column that it can use to filter the time range that I gave it. And this is pretty cool, even though all the column names and a lot of the data is in Japanese, because it's AI,
Yeah, that's
it
pretty
knows
cool.
what it knows what all of it is right now.
All right, Chris, I'm very excited to be doing this together. Thanks for taking the time. So to give a little bit context, a week ago, you showed me you've built some new things in Fuse with some of the latest tools that we have in Fused, and it's some very cool demos. So I thought we could go in and show what you've been building. So to kick it off, could you give me a little bit of background about what you are doing, who you are, what you're working on, and then take it away.
Sure. So my name is Christopher. I'm a data scientist for Pacific Spatial Solutions, a geospatial consultancy based in Tokyo, Japan. So I've been using Fuse for multiple years now, and recently there's a lot of changes to Fuse and Fuse Canvas specifically. So I've been using Fuse Canvas to create these two demos that I'll show today regarding regarding basically disaster prevention and disaster prediction. It's a common thing we do within Japan, so that's what I'm going to be showing off today.
Let's do it.
So let me quickly share my screen. I'll do my window here. This should be visible to everyone. So at the time of recording, there was a expo yesterday in Japan, which is what I created these demos for. So there will be a lot of Japanese text throughout these demos, but I'll try to run people through it. You're going to have to take my word for it with the translations. But what we're looking at right here is basically, it's a data set that I've shown off before, but it's open data from the National Police Agency in Japan showing traffic accidents all over Japan. So this data is openly available. It is published as CSV files from their website, and they can be directly accessed from there. So I wrote this UDF infused, which will go directly in and grab those files. Python, using a library called pandas, can directly remotely read those CSV files and bring them in. So that's what this main block here does. So then attached to that up here in the top left, I have these two widgets. So these widgets will give me the access for multiple years. So on the website, there are multiple CSV files, one for each year. So in here, I can basically say I want the data for 2022. And on the right here, there's a different list of exactly which area of Japan that I want. So at the top here, it says all the prefectures. So Japan is divided into these districts called prefectures. But this will basically just say, give me all of them. Or maybe I only want Tokyo. Well, then I can find Tokyo on the list here, or Osaka. Then I can find Osaka on this list. But for now, let's just say we want everything. So then everything for 2022 will give us this table right here. And here we have all the data. We can scroll through it. We can see we have columns like month,
Could you make
day.
it maybe a little bit bigger, Chris?
Sure.
Yeah.
There we go. We have stuff like month, day, hour, and then the age of the people involved, how many people were injured.
I'll take your word for it, but it does look like it, yeah.
So this is A here A means the party A, and B would be party B. And then we have the number of people injured here, and then the latitude and longitude at the end. So then if we move to the right here, this main table then flows into two widgets on the right here. The first widget we have is this kind of interactive map. Let me zoom in a little bit. So this map in itself, because we queried all the data, it has all the data for that year shown right here. But we also have this AI chat on the right here. So let me quickly zoom in here. So I can say something like, show me accidents from Osaka between 10 a.m. and 5 p.m. So what should be happening right now is behind the scenes here, it's going to go in and change the underlying query that is visualizing this data, and then query the data, this main data right here, in exactly the way that we asked it to. So it should go in and figure out that, hey, I have a prefecture column, which I can use to find Osaka. That's what it's doing right now, as you can see. And then it's got this hour column that it can use to filter the time range that I gave it. And this is pretty cool, even though all the column names and a lot of the data is in Japanese, because it's AI,
Yeah, that's
it knows
cool.
it knows what all of it is, right? I can ask it in Japanese, I can ask it in English. For this demo, I'll use English, of course. And then, yeah, so this is basically all the accidents that happened in Osaka Prefecture. You can see like the border here between that specific time frame. We can also say, hey, okay, how about you plot Tokyo for the same time frame? So now we should go in and then recreate that query to also show us Tokyo, and it even gave us a different color, which is handy so we can see exactly what the difference is. And then this is then the same time frame, just for a different part of Japan.
And so here, because you have that node, that arrow between the data and the widget has access to that data directly. So it can
Yes.
pull the columns, it can pull everything. That's why you don't need to say this is this column and that column, because you've created that arrow. So this widget component, which is the same thing as the dropdown, by the way, that you had. It's just there's some input and there's some output ones. It has access directly to the data that you're passing. And because, yeah, it's an LLM, it can figure out, you mean this is the character for prefecture in Japanese.
And it knows all of it. And I think one thing to point out is that you're just giving it the information that it needs to restructure that query. That can then, because you could do this yourself if you really wanted to, but it would take you so much longer to first filter the table exactly the way you want, then recreate a new map only showing that data. AI will just do it for you directly.
Yeah, under the hood, the widget is writing a SQL query.
Yeah.
It's writing the map that you need and a SQL query that says, here, there's all this HTML accident data for 2022 because you already filtered it. And then it says, select values between where prefecture equals Tokyo. And then it visualizes that and makes another layer, and prefecture equals Osaka. We're using the AI to create the widget itself and to query the data. Both of those things are happening at the same time.
The whole thing. Of course, in this case, it changed the color for us as well, right? Which is nothing to do with
that's pretty cool.
With the data query. This should hopefully work, right? If I open this in a shell link, yeah. So now we can basically take that map, and instead of just showing it in the canvas, we can have a whole full-size map of this same data. So it's a different way of interacting with the map. Usually when people want to see the data, they want to see it on a bigger screen. So you can easily just do that with one click. And then let's try to push it a little bit. Let's say show data from Kyushu, which isn't a prefecture. It's a region of prefectures. So it needs to figure that out, where the age of either driver is above. So what should hopefully happen here is you go in, figure out exactly which prefectures are within this Kyushu region, and then find out that we have two columns with the age, and then show.
Can you again make your screen a little bit bigger, Chris? Just so we see a little bit what's happening.
There we go. Maybe a bit more.
Yeah, that's great. Thank you.
No problem. So then here we go. This is basically the data from this Kyushu region I was talking about. It figured out exactly where those prefectures were. It even gave me a little color here of the number of injuries, which I didn't even ask it for, but that's super cool. So here we can see the colored points are the number of people injured. Yeah, red would be more people injured in that accident. And it has also filtered it based on the age of either A or B. You can see up here that it correctly found those two exact columns that I described earlier. So yeah, it's super powerful what this can do. And let me jump back to the demo.
While we're here now, you're in the workbench. I wanted to go, if you could show in the HTML accident how you pull the data, because you said it's a CSV. And so it's just a hosted file that you're pulling, and then you're writing here in UDF and the user-defined function. This is the serverless function. That's why you can then share it as an individual link. Again, if you can make just your screen a tiny little bit bigger.
Sorry. One more time?
Yeah, let's do one more time.
Okay, there we go. Sure. So this is basically the Python code running behind this main UDF. And I think we've got this function called get CSV from page, which is where the main part is happening. So let me open this up down here. But we basically use beautiful soup and requests
very basic Python
to basically some very basic web scraping, finding the links depending on the year. As you can see here, it gets the year as an input, and the main page URL where those files live. It will then use that to filter out all the files with that specific year, and then get that one specific file that we're interested in. And then down here, there's a lot of translation and stuff going on from Japanese to English. Now it's actually Japanese, so I don't need this on anymore, but there's a lot of stuff like that, just to make it more readable for us and for me and for our LLM, because the default names were quite cryptic. So this helps with that. But yeah, nothing really that fancy going on. It's around 100 lines in total, I think. Yeah.
And then you have some other visualizations where you have the same data and you're saying, well, I don't necessarily want a map. I can...
Yes. So here we have a bar chart, and I have also attached AI to this one, just because why not? And for the bar chart, this is mainly to get a quick overview of something very specific. Maybe you don't necessarily need to look at see the data on a map. Maybe you want to instead say, let me zoom in a little bit, show data from the summer months. Because right now what we have here is a bar chart that shows the number of accidents per month across all the data. So then we can say show the data from the summer months, and then here we go, June, July, August. And then these are then those counts. So 25,433, 401, and yeah, 543. And then we can also do show number of accidents by age for the winter months. So then instead of now showing it for each of the months, we should have it grouped on the age instead, and only
Yeah.
for the winter months.
Well, did you also try asking it to make a slider, for example, of available months to start on a given month? Like that's the other thing that you can do is you can add not just the visualization, but you can combine something like the dropdown that we had before, or a slider, or some other form of interacting directly with the widget and combine them together.
So I have not tried the actual slider itself, but I've seen it done, and it's something I should
You want to
be playing
try it?
around with
Let's
some
take a
more.
risk. Let's try it.
Be say, okay, make a slider for months.
Yeah, like the beginning months of the like the first month of the filter from the whatever first months until December, something like that.
That allows us to select month. So then we can kind of select how many specific months we want.
Yeah, something like that.
So it kind of stopped before, but hopefully it should
It's we lost
try again.
in the actual next version of this, the one that's just about to come out. We have the AI that's trying again, so you don't need to tell it to try again like that.
I see. So it did get the slider.
Yeah, I think it got confused from the. If you refresh and ask it again, because I
Sure.
wonder if it got. So if you say here now, add a slider to select the first month. So then again, it like pulls. It has access to that data. It sees what it it needs to be able to visualize it, but then it can also create an input and then connect the two together. No, it really doesn't want to do it.
It's probably like there is definitely something going on with the Japanese
All right,
characters as well.
we'll skip that one.
It's all good. But yeah. So then moving to the last part, we have the time series, which will show you the number of injured people of any part of the year or week or month or whatever you're interested in. So down here, you can then choose the sliding window that you specifically want. And if you hover over the graph here, you can see exactly how many injured people we had, which is very, very interesting to be able to see where the peaks are, right? Like where do we have the least amounts and where we have the highest amounts. And for maybe like a certain season, you could like make this very, very short and then look at right at the end of the year. And you can see as we approach the end of the year where people are spending time with, friends and family and so on, and they're not driving as much, especially like during New Year's Eve and Christmas and so on. You can see how it dips very far down, which is what we would expect. So that's nice to see.
So yeah, this widget here allows you to have all these different ways of just you have the same data set, but it allows you to just visualize it in a whole lot of different ways in a much more intuitive way without having to go write a bunch of SQL.
Yeah. And I've only shown like 2 or 3, if you count the map, different widgets, but there's like 10 or 15 or 20 different widgets. And if you just talk backwards and forwards with AI and nudge it in the right direction, you can make some really powerful widgets. And all this is just written in JSON, right? Which is the most amazing part. Like no HTML or large amounts of front-end code you need to write yourself. It's just a few lines of JSON, and then you've got a very powerful visualization.
You had mentioned you had another example?
Sure. So this is slightly more advanced, not in terms of the canvas itself, but I think in terms of some of the things that I'll try to explain. But the main purpose of this canvas is to show where are the highest earthquake impact happening in Japan. And by earthquake impact, I mean a population being impacted. So where are people living and where is the highest risk of earthquakes happening? So at the top here, there's a little quick visualization and all the links to the open data that has been used for this. And we have 3 layers. We have the population layer, we've got the earthquake risk layer, and we have the name of the municipality as well. That's good so we can actually connect these values to actual names of places. And for the earthquake risk itself, it is the risk or the probability between 0 and 1, where 0 is 0% and 1 is 100%, that an earthquake will strike an earthquake with a magnitude of 6 or more will strike that area within 30 years. No, it's a little bit, it's a long description, but it basically means what's the risk of a large earthquake hitting relatively soon. So in this table, which is a joined table, we have also hexagonified the data. I didn't mention that, but it means that we took these different raster and vector data, and then we converted it into a hex format, the hexagon format, which people might be familiar with, which that gives every single little cell its own basically address, and it's very easy to join different data sets on that. So for each hexagon H3 index, we then have this earthquake risk that I mentioned, and the population here. So this is the estimated population in 2020 and in 2025. And then we also have the name of the prefecture and the municipality city. So that's our main source of truth table. So connected to this table have, similar to before, we've got two widgets. This one is slightly different though, because here we have AI attached to the table itself. So this will help the user quickly sift through the data and directly ask questions to the table instead of having to write SQL themselves. So we can do filter the table by the cancer region. So then instead of having to go in and find exactly which prefectures are in this region, we can just ask AI and it'll figure it out. And then it only shows, yeah, okay, these are the prefectures in the region, and then it filters directly on those.
Yeah, this is
So-
great. If like you said to me, hey Max, like go, here's my data, go keep it just for Tokyo. I don't speak Japanese. I don't know what it would look like. And this is really powerful.
And then group by prefecture and municipality. So then we're grouping for each municipality within this region, and here we have got the total population for the population column, so that's a sum, and we have the average earthquake risk in the earthquake. So then if we just press this once, or twice rather, we get the highest average earthquake risk of municipality, which is here in Chiba Prefecture next to Tokyo. And then similarly, we can also, where are the most people living? Okay, it's this place. And then we've got a similar bar chart as before. We already mentioned this. So yeah, this will just give you the average earthquake risk across all prefectures. We could ask again, but yeah, same thing. But the interesting thing is actually down here. So below this main table, let me just make it full screen, we have another widget where we can select an area of Japan similar to what we saw on the accent data. But when I do this, this will send that prefecture's data down to these two sub UDFs below, which will aggregate it in different ways. So on the right one, it'll aggregate it the same way as it showed before, and then feed that data directly into this donut chart, which will tell us exactly what we want to know. And by that, I mean the earthquake population impact. So the way that I calculated this is a very simple way. It's definitely not the best way of doing it, but I just took the probability and then I multiplied it by the risk of an earthquake. So that basically means that the higher the number of people living there and the higher the risk is, will give us the highest number. So for this specific prefecture, we have the top 10 highest earthquake impact cities and the value assigned to them. So this gives us a very quick overview of where are the most cities within this prefecture that are most that are going to be impacted the hardest if a earthquake hits, because there are plenty of areas in Japan in the mountains where earthquake hits, but no one lives there. So this, gives us a good overview of where to focus when it comes to disaster prevention and creating places to evacuate to, and make buildings earthquake proof and so on. But yes. So then for the left sub UDF, here we actually need to keep the hexagon index because that's what we're going to be visualizing in this very last widget. So what this does, it just keeps the H3 index for all of that prefecture so that we can then visualize it here. So the prefecture that I chose was this very large one in the north of Japan. And this is actually 3D because it's hexagons.
Oh, that's really cool.
Because it's hexagons, we can base the elevation off the population values, and we can do the color based on the earthquake risk. So we're not calculating anything here. We're just saying, here are two colors. And what stands out is, okay, if a color is very dark and the cell itself is very tall, well, that means that we have high population and high earthquake risk. So at a glance here, we can see that the cities on this coastline are very prone. I think that's because there is a earthquake fault line here in the ocean, but they're all very prone. And this smaller city here, you see there's quite a little bit of a population here. And moving down, we can just quickly find these.
And this is just the same table. You've just made another quick widget where you say, hey, visualize it. And now you can actually just see it directly. If the data was to change, the map would directly change as well.
Yeah. And for this, we can also open it in a link. And if we want a little bit of a bigger map or share it with someone, I can just quickly do this. And one thing to note up here is that this, up in the URL here, it has already remembered what I selected. So it knows exactly what data to show. So it remembers that selection from earlier. and then I can just share this with someone.
So if you go back to Canvas and you select a different prefecture.
I'm glad you asked me that. So let's do this one, Chiba, next to Tokyo.
So then it goes in, it basically runs the UDF to do the filtering.
Yeah. So
you
can see
get
now
a
this
new donut.
Yeah. Going up here, and then if I zoom out, then yeah, now we have a different part. And you can see there's a little part of this prefecture very close to Tokyo. So you can see how the population grows very large here. And this specific area is very earthquake prone as well. So this would be, a very important place to make sure that this is to focus on for this type of analysis.
And then if you share this one.
Yeah, then hopefully what should happen is we should have, this value up here is updated. And after a few seconds, here we go. And all this data is, is cached. So it might take a few seconds the first time, but this will be, instant whenever you share it with people. And even if people hit this endpoint 100 times, 1,000 times, it'll just show up exactly like this. Yeah.
This is super cool, Chris. This is really, really cool.
This was mainly just an exercise for myself to get familiar with Canvas and all the cool things you guys are building, especially with the AI widgets. It's super cool to play around and in natural language.
Yeah.
Because sometimes like AI will give you a visualization of something that you haven't even thought of yourself, right? It will it will show you a bar chart in a way where you're like, wait, maybe that's actually a pretty good idea to color it this way or to structure it this way. And then, if you just want a good old map, that same thing. It's super
map,
easy.
Bar chart, a lot of these different visualizations.
This 3D map that I'm showing here, it's 30 lines of JSON. That is very impressive.
That is also, so that's what's happening under the hood on the JSON, on the widget, is that it's using this JSON syntax. So it doesn't go completely crazy. It doesn't write HTML. It doesn't have to reinvent the wheel for what a map is every time, or a chart or something like that, because we've given it this widget. And then if you can show, there's actually a little SQL that's written in there, just sort of for the behind the scenes of how this whole widget works. You can see here line 11, this is what the AI writes for you, is it writes the SQL. This is parameterized, so prefecture UDF hex is actually the data. So this widget loads this data, this UDF that you have. So it's very easy to say, hey, I have this data set. I'm going to write a UDF. It's all serverless, so you don't need to set up any infrastructure or anything. There's the multiprocessing, so you can, join a lot of data together and then just simply pass it to a widget. And then you have your visualization here that you can share out. But there's like a few reasons why it's very interesting to have this JSON. One is that the AI doesn't go loose. Two, when these models get more and more expensive, it actually is a lot cheaper to make iterative visualizations because you're not generating a visualization from scratch. Like the amount of context that your LLM has is much narrower because it's just this JSON format. And then you can ask more questions for the same number of tokens without burning your credits as much. So there's like these multiple benefits that sort of stack on top of each other here.
And I think that's credit to, the Fuse team that you're not trying to reinvent the wheel here, right? See, I've seen some places where you can do AI-powered visualizations where it will, as you say, try to generate the whole HTML and everything from scratch. But we already have those things figured out. So why not just have AI generate what it's good at, which is this JSON text that most LLMs have been trained on trillions and trillions of rows of JSON. So if you could just put this one layer above the visualization and then just only have the LLM interact with that, the thing that it's good at, then it's not going to mess up as much.
Yeah. If you don't mind, I'm going to share my screen real quick,
Sure.
Chris. I want to show people, if people are interested and they want to learn how to be able to do this themselves, I'm going to share my screen if Riverside allows me to do it. Doesn't seem like share. I can't share my screen. What? Okay, that's an interesting one. Well, Chris, I'm going to ask you to do it. If you go to the workbench, just the home workbench. If you share your screen and go to home workbench, I don't know why I can't share my screen.
No problem.
Okay. So if you go to the home, if people want to learn how to do this, there's this basic example. The very first one. So if you go to fuse.io/workbench, you will get this basic example where we've actually embedded, there's a widget here at the top of me doing a demo of just explaining this. So people can watch a video directly of this. But at the bottom left here, you have a small Airbnb data set, place locations. You can see when Chris here, you click on it, it just reads a file from Parquet from S3. Like it's very, very simple, but you have access to everything on S3. And then on the side here, you have this widget, and you can go in and you just need to be logged in to be able to access it, because it's AI and we're using credits. So we don't want just anybody to be able to go there. You just need to make a Fused account and you can start using that. And so in here, if Chris, you ask like, show these points on a map, it's the same widget that we have here, and it's going to do the same thing that you were showing. But this is like a very small tailored example that people can start with. And then if you want to iterate on it and play around and see how it works, at the very top right, there we go. And then we get this map of like the data. The sizing looks a little off, but I think that's maybe just because it's this stock widget because it's in the shared view. But this is more as a playground for people to see what's possible. And you can see we went from a chart to a map, basically. And this just visualizes the data set that's on the side. And so if you're then, cool, I want to play around with this, there's this button, make a copy at the top right. People can go click on that, and that will just bring it into their workbench, and you can start playing around with it and iterating. I just wanted to say that if people are like, oh, hey, this looks cool, how can I get started with this? You can make a free account to go to fuse.io/workbench. And that basic example there it has most of what we just talked about here with you, Chris. So that's a great way to get started on that. All right. Well, Chris, I also know that since last time we talked, you've been using Canvas more. I'd love to just have, maybe some closing thoughts on what you think of it and how the experience has been overall.
Sure. So up until recently, I pretty much exclusively used the map view, and Canvas seemed somewhat daunting to me. I've always wanted to make dashboards, of course, because that's how non-technical people can interact with the technical stuff that you're doing. So before that, I was just doing screenshots from map view and sending that and sharing that instead. But recently, with a lot of changes with how all the widgets are now simple JSON, and it's like a drop down, you just pick which widget you want, you connect the data to the widget like that. You can even have AI help you write them out. And even if AI writes it for you, it's still very simple to understand what it did and what the widgets do. Due to these changes, I dove back in, and it's been fairly simple for me. I can use the same UDFs that I used for the map view because they return a data frame. And then that data frame, I just connect it to these widgets and get the visualizations that I want. Yeah.
One thing you were also telling me is you were a little bit sick just before a few days ago.
Yeah.
So at the expo, you actually passed this over to your boss,
Yes.
and he was able to just do all these demos directly, because all of this is, it's not running on your laptop or something where, you need to, it's very complicated to set it up. You could just share the whole canvas and then say, hey, here it is. And you can just directly run with it, which I thought
he was
pretty
sharing me
cool.
screenshots of how his dashboard looked quite different from mine because he'd gone wild with the AI and asked it a bunch of stuff in Japanese and changed it to a chart that he thought was better in his opinion. And I think that's the beauty of having this AI connected to the widgets, because who's to say that the person who makes the dashboard knows exactly what the widgets is supposed to look like? That should be the user who chooses that. You can give them an idea of some cool things to show, but depending on the person, they might want to show other parts of the data. So having that option, I think, is very powerful.
Cool. Well, Chris, thanks a lot for taking some time to show everybody like what you've been building lately with Fuse and trying it out and doing live demo as well. I always appreciate that. So thank you very much. And I'm sure we'll do another one of these soon.
Yeah, it was mainly for my own sake. Hopefully people find it interesting. If they have questions to any of it, I am planning to make this public as well so people can try it out themselves.
Yeah, we might have some link in the description for these. Yeah.
If people are interested in it or, they want to ask questions about it, they can just reach out and
and then again, go to
questions.
fuse.io/workbench if you want to try it out. You can make a free account and then just try it out directly for free. And I can't stop the recording. I cannot pause any of these. I am stuck. I really hope it doesn't screw it up. That sucks. What if I close this and then I stop here? What happens? Shit. Okay, that sucks. I really hope this is all working fine. I'm gonna leave the studio, see what happens. I'll just come back. I also cannot leave.